Okay, welcome everyone to another session of CHIWORK. It's the Symposium on Human-Computer Interaction for Work. Today we have Dr. Lewis Chuang of LMU Munich and the Leibniz Institute for Working Environments and Human Factors as a guest. And before I introduce him more properly, let me briefly introduce CHIWORK. In the CHIWORK series, we have weekly conversations with experts on various aspects of the future of work. The general chairs are Andrew Kuhn and Orit Scheer, and the technical program chairs are Anna Cox, Nea Kumar, Lena Mentis, and myself. My name is Chris Janssen. We have a fantastic team of volunteers that create these series, and you can find out more about them and about future CHIWORK series on www.chiwork.org. There you can also find a link to register. If you register, you'll get information from the talks and calendar invites right away to your inbox, so that might be convenient. We are recording this session, but we also love to see you. If you're in a position where you can turn on your camera, we'd love to see you. For the recording, it only records whoever is talking, so that will mostly be Lewis and me. But once we're at the way we'll structure the conversation is that we'll roughly talk for about 30 minutes, where I will start with asking Lewis a couple of questions, and at a certain point we'll move to the audience-driven questions. So if you have any questions, please type them already in the chat, and I will give you the floor once we're at the Q&A part. After the conversation, we'll stop the recording, and then we can have more informal conversation as well. With all that, it's my absolute pleasure to introduce Dr. Lewis Chuang. We know each other for quite a while. It's a pleasure to have conversations with him each time. Lewis is a lecturer at the Ludwig Maximilian University of Munich and senior researcher at the Leibniz Institute for Working Environments and Human Factors. He will be the professor for humans and technology at Chemnitz University for Technology from April onwards. Congratulations. In his work, Dr. Chuang employs a variety of techniques from behavioral neuroscience and task analyses to physiological monitoring, psychophysics, and applied computational modeling. And his goal is to understand how people interact with digital technologies and automation. Dr. Chuang co-initiated the section for engineering psychology of the German Society for Psychology. And he's an associate editor for scientific reports and the International Journal for Human-Computer Studies and for Frontiers in Neuroergonomics. And he was also a technical program chair for Automotive UI and a general chair for last year's Neuroergonomics conference. And today we will be talking a bit more in depth about neuroergonomics in its various forms. Welcome, Lewis.
Hi, thanks for the invitation, Chris.
Yeah. So in the abstract that you provided for your talk, I think you already posed the intriguing question, right? So you wrote that our ability to work is often quantified in terms of performance, speed, accuracy, and how can we be even faster, even more accurate? But that the age of automation is changing that a bit in the sense that maybe we aren't always doing the task. So how accurate we are, how fast we are as humans might not be the right measure. And then you say, well, but let's look at techniques from neuroergonomics to solve this problem. So can you maybe, for those that are less familiar, briefly explain what the field of neuroergonomics is and how that might solve that problem?
Right. So many of us might be familiar with the phrase or the term ergonomics, right? And traditionally, ergonomics has a lot to do with the physical side, especially of human performance. How should we sit? How should we stand? How much weight should we carry in a way that's healthy, right? So a lot of it focuses on the physical aspects of our physical well-being. And even as I'm saying this, I'm very conscious about my slouch as I'm sitting on my office chair. So as time progressed, there has been this acknowledgement, of course, that a worker's well-being isn't just about the physical aspects of things. and hence crept in the term human factors, right? So we're interested in all factors related to human that could be relevant at the organizational level, in terms of training, for example, so on and so forth. But increasingly, as we know more and more about how the brain might work and brain mechanisms, there's been this push from a community towards the late 80s or the early 90s towards trying to understand work in terms of information processing, in terms of how the brain might be processing information, and how could we potentially be redesigning work to make it easier, so to speak, or better for the brain to be processing information, so to speak, given what we understand of neural mechanisms. So that pretty much is what neuroergonomics is about. And in a nutshell, it's the application of neuroscience theory and methods to understanding the well-being at the workplace or everyday work. Yeah.
Right, and then you tie it also, at least in the abstract. I think in your work you look a lot broader, right? But in the abstract you tied it to the situation where we interact with automation. So how's that link?
Right. So, well, so this is the pitch, right? Like, why should we be doing neuroergonomics? And not only is it a pitch, it's something that I feel quite strongly about. So first of all, if you're applying neuroscience methods or psychophysiological methods to understanding someone whilst they're working, right? Let's say EEG or electrodermal activity or you know, heart-based measurements, which arguably has not very much to do with the brain, but I might beg to differ. But the bottom line is this: if you're measuring these physiological responses of the human at work, then what you get is a continuous, uninterrupted measure, right? Which of course you will summarize and treat as potentially a single metric for the duration of which you're measuring for. But nonetheless, you're getting a measurement whilst work is being done. You're not interrupting work to ask the person, so how did you feel about the last 10 minutes of working? A probe which in itself could constitute part of the work experience itself, right? So you might be inadvertently altering the work experience with explicit measures. So neuroergonomics provides an implicit measurement, so to speak. Yeah? It's not a replacement. I mean, you're never going to get the level of explanation or nuances that you could capture with an interview or with a questionnaire, because, well, the interpretation of implicit measurements are still going to be subjective to the experimenter. But it certainly solves a challenge posed to explicit measures, and quite rightly so, right? In terms of performance, so that's the other side of things, especially in the age of automation. Arguably, a lot of our work is going to happen without any explicit responses, right? We might experience increasing stress whilst thinking hard about how to write a paper without once actually pressing the keyboard, right? So where are you going to get your responses from, right? So you might be getting your responses from how the body is responding to that mental workload or that stress. Well, that's one possibility. So that's how I see neuroergonomics being part of the puzzle towards understanding the challenges that we face in everyday work.
Yeah, I mean, I guess like any measure, also the interviews, I think you're putting the interviews maybe too much on a pedestal, because even there's a question of interpretation, right? Or connecting it to theory, just like with EEG, but maybe
Sure.
in a different way. So pros and cons, but it's a useful measure. So let's make it a bit more concrete. So you've done a wide variety of studies in this area. And we've discussed a bit before, well, what can we talk about that's also interesting to the community, right? So a lot of your work has been on electroencephalograms, EEG, with ERP, event-related potential measures, to study how well information is processed or detected. And in an article for Human Factors, you and your team studied inattentional deafness. So could you maybe tell us a bit about that study and its findings in a nutshell, sort of like, well, how that's sort of illustrative maybe of this approach?
Okay, so I'm going to roll that back a little to talk about stuff that I'm not responsible for, but a phenomenon that was really quite surprising, right? So we've known about the basic phenomena in psychology of things like phenomena like change blindness or inattentional blindness, right? Or inattentional deafness. And what that fundamentally means is if we're really focused on doing something, we might be perceptually blind or deaf. I'm not sure if those are still appropriate words to use, but in the context of the experiment, those are still the terms, yeah? To stimulus that are unexpected and appear out of nowhere. Okay, so that's a basic psychological finding that's quite well replicated, and it's usually linked to selective attention, so to speak, in the psychological research. Now, what's interesting is when it's actually applied to the context of work, right? So Frederick DeHay from Toulouse reported that when he tested 28 well-trained pilots who are still flying commercial airlines, when he tested them first in the simulator and then whilst actually flying, 11 out of 28 of them demonstrated the following phenomena. When they were asked to try to land a plane on a landing strip under highly turbulent conditions, they failed to notice an unexpected auditory notification that told them to abort landing because the landing wheels or the landing wheels will not deploy, right? So they were so focused on the one task of landing the plane that they didn't realize that there was a greater danger in actually landing the plane as prompted by this auditory notification. So here's an example where basic research in psychology actually informs us about a risk in everyday work, right? Now, so what do we do then? And this is where the subjectiveness of interpretations from so-called objective measurements of EEG comes in. Fred explained this, or the common explanation would be in terms of mental workload, the cognitive load, right? That the pilots were so stressed and had so much cognitive load in terms of handling the controls of the plane under turbulent conditions that they failed to notice a sound that happened so rarely that they weren't paying attention for, even though they were trained to recognize it, right? And they showed with EEG-ERP that indeed the brain's response, involuntary response to these sounds were reduced. But we wanted to generalize it, right? So we wanted to generalize it and we wanted to show it as a phenomenon not just taking place among highly trained pilots, but something that actually affects us all humans at a fundamental level. So what we did differently was this. In the lab, under laboratory conditions, we actually tested undergraduate participants and simply asked them to do a steering task whilst playing them environmental sounds. So sounds of things that they might encounter in the environment, like a baby crying, a cat meowing, so on and so forth. And what we told them was this: the sounds that we're going to play to you, they're just part of the environment. Just ignore them. They've got nothing to do with the task. Just try to focus on steering, right? But nonetheless, the brain will evoke a signature response every time it hears a sound, so long as it's processing that sound, right? And indeed, you get a signature waveform if you average all the brain responses every time it hears a sound. And by manipulating the steering difficulty, we could show that we could tell at which part of this ERP waveform might be kind of affected by our manipulation of the steering task itself. Now, one key finding that we found was that if we told participants that the auditory channel was completely irrelevant and they should just focus purely on steering, the overall waveform had smaller amplitudes, suggesting that they literally ignored the auditory channel, right? If we told them that there's going to be a very light task in the auditory channel, that the environmental sounds are still irrelevant, but now and again, you might hear just a ping sound, okay? Where you just have to press a button to show that, hey, you're still paying attention to the auditory channel. The responses to the task irrelevant environment sounds actually increase, right? So this would suggest a general or generic allocation of resources, if you will, to the auditory channel, and not necessarily at the cost to steering. So what does this mean in terms of automated vehicles when, for example, Waymo or Tesla decides to deploy them? Right now you have L2 vehicles where you have automated driving, but you still have to pay attention to the road, right? And if nothing happens on the road, as it should be if automation is working well, what it suggests is that people are going to shift away spare resources away from the road to do something else, right? So what might be a sensible mitigation to that would be to say, rather than to tell people you have to pay attention to the road because an L2 vehicle requires you to pay attention, what you might choose to do is to actually ask them to just press a button whenever a signal comes up in the visual channel, for example, just to evaluate whether or not they're paying attention. And simply telling them that this might happen might be sufficient in just maintaining some level of vigilance, right? So instructions alone may not work, right? So this might give some insight into design. Yeah, and I'll stop here because I tend to just go on.
Well, I was taking notes on how you explained this paradigm because you know we've used similar paradigms. I liked how you explained the paradigm.
I'm sorry, and I should have, of course, cited your work as well.
No.
But you've gone on to do some really nice work as well.
I'm making notes on how you explain it because I can use that way of explanation. We are moving forward with time, but I do want to touch maybe a bit briefer than we had planned on another study, because I thought that was also very insightful, where you compared professional truck drivers and how they processed information. So slightly different paradigm, but sort of comparable techniques, right? And there you found the reason why the EEG was extra information, because I think the behavioral measures didn't solve it. Can you explain that maybe briefly, because then we need
I'll try to be brief,
time for the audience.
Yeah. So if you've designed a fantastic auto driving truck, what do you need? You need fancy notifications to still keep the truck drivers in the loop, and that indeed was what Scania did, right? So they invested a lot of funding in trying to design, you know, really nice notifications with lots of feedback for telling the drivers what may or may not be happening, as you know, or what the truck might be doing. And then at the end of it, they went, okay, well, we have to decide between which variations of the same notification to use. Should we use a verbal command? Should we use an iconic sound, or should we use an abstract sound? And what do you need? What do you do when you need to make a choice? You do a user study, right? Now, their user study involved presenting these sounds and asking truck drivers, or sorry, rather undergraduate participants, to as quickly as possible press the button when they've heard the sound and recognize the sound, right? That was the user study, and I'm not saying that's wrong. What I'm saying that the conclusion might not have been sufficient, because on the basis of this user study, they made an argument for verbal notifications. Why? because verbal notifications were most accurately categorized and fastest to respond to. What we did with EEG-ERP was to go, hang on, wait a minute, do you really care about these milliseconds differences in response times, right? Or these 3 or 5% differences in recognition accuracy? I doubt it, right? What you really care about is how people actually might be perceiving these sounds. So with EEG-ERP, we were able to show, first of all, that the brains of Swedish truck drivers are not dissimilar to German university students in terms of hearing these sounds, right? So you still see the signature waveforms. So that's good, right? But we also showed that there's no such thing as a perfect notification. Yes, verbal notifications resulted in larger early brain responses. And looking into the literature, it might be because our voices occupy a very specialized bandwidth, right, of the sound and of the auditory environment. So it is easier to discriminate it from the environment. But nonetheless, the auditory icons, like a raindrop to indicate changing weather, that rain might be upcoming, actually resulted in larger amplitudes in the ERP waveform, but later on, which is commonly attributed to contextual updating, the processing in which it suggests that, hey, the statistical frequencies of events in your context might be changing now, right? So we came away with a more nuanced perspective of the sounds to say that there's no such thing as a perfect notification. It's not a competition between verbal or auditory icon, but rather you should be using different sounds to do different things. If you want people to respond fast, maybe use verbal commands. If you want people to kind of get a sense of what's changing in the background or in the context, you might consider icons instead. But I say that with caution because we really need to be doing a lot more research into that, for which I've not received funding yet.
Well, hopefully that will come your way, because it's really cool. Like
after today's talk, it will.
So that makes them over to me as well as the person who invited me. I'm happy to collaborate if you swim in the money, but no, you can keep it. No, I really like it's a nice study design with actual professional workers, where it shows where the differences are between what we do in the lab and what those professional workers do and what they do in an actual sort of task relevant context versus really more controlled. So it's really nice. So we step back a little bit from the specific studies. One of the things that I also get asked is, do you really need that specialized equipment? or can you use the commercial off-the-shelf tools, or do we really need the more specialized hardware and software? And of course, the answer there is quite nuanced, but I'm always asking fellow researchers, where do you stand on this question? Like, can we solve these neuroergonomics problems with off-the-shelf tools, or do we need to specialize tools? And then maybe after this, we can take questions from the audience. So get them in. Yeah.
So the answer is my favorite German word, Jein, which is a combination of ja and nein. So my own group have published studies that have used off-the-shelf so-called commercial systems intended for meditation, right? That costs 700 euros, like the Emotive or the Muse, right? And we've been fortunate that it's been, accepted by peer review. And the reason why it's been accepted by peer reviewers is not because we've done any seriously fancy analysis on it, but because we've made an argument of the signal that matched the claims, or the claims of the contributions. Let me explain. So when you perform any study, so let's move away from the measurement system, you want to get an effect, right? And that effect is going to have a size. So it really depends on how large your signal is and if it will show up against the noise in your entire data set that you're recording. And there's several ways to boost this effect or the signal. You can design the experiment such that it really reflects the mechanism or the brain response that you're interested in. And that's what psychologists are really good at doing. They come up with very clever experiment designs. But in doing so, they might move away from the naturalistic environment of work, right? So if you run very highly controlled and well-defined studies, you're going to get a larger signal. There's no surprise at the cost of, but is this really generalizable to the work, right? But even before then, you need to identify what this effect might be and if it's a reliable effect. And the only way to do that is by reading the literature, right? So this means that if you're an aspiring neuroergonomist who's interested in everyday work, it would still pay off for you to be reading the so-called basic sciencey papers, right? Because they're going to give you a sense, even if it's informal, of the size of the effect that you're going to see. With EEG, in my case, that's why I focus a lot on auditory notifications, because auditory potentials are large, right? I would, however, cash out for expensive equipment in some cases, because it's a lot cheaper to pay for high-end EEG systems that can pick out the electrical signal from the electrical noise. And I say it's cheaper because the time of a scientist is extremely expensive, right? So you might end up spending months and months just denoising your data, which might not be worth it, right? Because that's not really scientific work necessarily, unless that's your interest. So it's a nuanced question in that sense. There's one more thing I want to add as well, sorry, and that noise is not just electrical noise. Noise can also be cognitive noise, and that's something that a lot of people forget about, which is why we need well-designed experiments. So it's unlikely that the brain is only doing or thinking of one thing at one point in time. What does this mean? It means that even if you're interested in only one thought process, you're going to get cognitively induced noise from all the other processes of what someone else might be thinking of in that moment when you assume that you're only measuring for that one cognitive process, right? So you come back to the point I said right at the very beginning, where experiment design is really key. You try your very best to design your experiment such that you're really measuring what you're interested in. Yep. And no equipment's going to help you with that.
I agree. I like this point of thinking about, keeping in mind that people are thinking about other things, because those of us who have been participants on study remember that we were sitting there and thinking about how nice it would be to have a coffee afterwards.
Oh man, I'm the crappiest participant in my own studies, I have to say. I'm always thinking about meetings and emails I've forgotten, even whilst doing my own pilot studies. So
I also liked in your answer that you highlighted the cost of the actual research and the analyses that comes afterwards, because it reminds me of the talk that Anna Cox said with Sandy Gold a couple of weeks ago, where we were all talking about, oh, how cheap it can be to get all this crowdsourced data online, similarly to just putting some electrodes maybe on someone's head, but that actually before the amount of time you've invested to get the relevant data out of it, and how you phrased your research question, that's also worthwhile time invested. And if you pay that much time to the researcher, then you might as well pay
absolutely
for your participants, right? So a nice parallel there. And that one was moderated by Anna Cox, and she is today my Q&A moderator. So that's the bridge to Anna. I saw that there were some questions in the chat.
Hi, Lewis. How are you?
Hi, how are you?
So we've got a couple of questions in the chat, but before we get to them, I thought I would sneak a question of my own in.
Oh, go for it.
So I think you started off telling us about this study, about this study with the airline pilots. And am I right that what they heard, the alert, was a voice command?
Oh, no, it was just it was an auditory
it's just a sound signal, like an alarm going
it's
off.
A sound that pilots are very familiar with. And you know, these sounds, especially in the cockpit, they're designed such that they're unique. they can only mean one thing, and they occupy a certain space in the auditory scape, right? So, well, yeah, so it's a well-recognized sound by the pilot. Yeah.
And so they would know what it means, but
If
the
they
implication,
perceive it.
yes.
Yeah. Mm-hmm.
So was it, so I guess that then you kind of went on to sort of say, when you look at the different kinds of sounds, if it's a verbal command, that's more likely to be perceived. Is that right?
So that was, yeah. So that is a separate study where we actually showed in the ERP waveforms that the earlier wavy bits of the ERP waveforms were larger for verbal notifications compared to these auditory icons. But the auditory icons were larger in the later part of the waveform, which is typically attributed to context updating. Yeah.
So is it that I guess what I'm trying to work out is whether an implication of your study is that the cockpit should be using verbal commands rather than the sounds to indicate these things. Because there seems to be a little bit of a difference in that. I think you were saying if it's a verbal command, people might perceive it quicker, but I didn't know whether that would really get round the problem of them not perceiving it, which seems to be the real issue in there.
Right. So there is a real reason why verbal commands are rarely used in cockpits, and I might be wrong at this stage, at this point in time. But my understanding is that verbal commands are really avoided, especially in a teaming environment where you have more than one pilot, because that verbal space is reserved for communications between pilots.
Okay.
Yeah. So there is a lot that goes into this. So this is why that I am very reluctant to make a prescriptive recommendation from a single study. But if someone would ask me, like, why would I consider a verbal notification? And if I was naive to the work context, I would say, well, on the basis of what we found, right, it results in larger brain responses at a time of the brain response that's typically attributed to attentional orienting, which suggests that it discriminates much better from the environment.
Okay. Yep. All right. Thanks.
Yeah. So that's how I would think about it. Yeah. Yeah. But there are all these other concerns from the organizational perspective, so on and so forth. So I guess we all need to negotiate eventually to find the sweet spot. Yeah. For notifications. Yeah.
Yeah. And so when we're thinking about actually applying these sorts of findings to the real, to real systems in real context, we have to think about not, I suppose the whole of the environment, the whole of the experience over a period of time, which kind of brings me to Andrew's question. So Andrew, do you want to ask Lewis your question?
Sure. Yeah, thanks, Lewis. This is somewhat really interesting conversation. Thank you. So I think a pretty obvious question is the difference between, a one-shot experiment versus longer exposures, because, listening to a relatively long verbal comment, command, instruction becomes, what's going to happen, right? At the moment you hear the first few sounds, you just cut it off. And so I'm curious what either your experiences are or something that you have perhaps looked at in the literature about this. So, the question would be, you're talking about, for example, how large of a response you're getting, but would you be getting that large response 10 weeks down the line, or would it basically fade away because you're like, look, it's just someone chatting away?
So I would say that the waveform holds. Yeah, okay. And it simply represents an involuntary neural response, or rather whole brain response, so to speak, at certain electrodes in response to hearing an environment sound. So this wiggly signature, where then you would be measuring different parts of and coming up with your subjective interpretations. That holds. You're never going to find a point in time where that waveform is flat unless you're dead. Okay, so That's the positive answer to that, right? Now, how might the response change over time? For example, on the first day of work, where you're excited about as a truck driver to be hearing all these fancy new notifications, to after having been on the job for 15 years and still hearing these same old notifications. I would argue that your brain would still respond in that way. Now, how your brain might have adapted to the redundancy or the meaninglessness of that information, so not the sound itself, but the information that you perceive it to be carrying, I think that's a topic of active research, right? And I don't have an answer to how might I expect it to change, but I would expect that if a given sound is repeatedly demonstrated to not carry information and to be irrelevant, that you would over time start to attenuate it, to ignore it. Sort of like if you're constantly told that you have to pay attention to the road whilst using your fancy Tesla, you might for the first week, right? But after that, you might start to ignore it. So I indeed, like you've spotted correctly, right, that these non-stationary states, our attitudes towards automation or technology, these are the truly interesting things to study. I don't think that it's just something that's a challenge for neuroergonomics, but it is a challenge for all different approaches to trying to study our relationship with technology and work. Yeah. That was a bit of a non-answer to your question, wasn't it, Andrew? It was an answer.
Oh, it's a good. I mean, it does orient me. So yeah. Thank you. That was good. That's
yeah. Well, we know for sure that adaptation is a key feature of how humans respond to stimulus, to stimulation. Yeah.
But I like your
adaptation
distinguishing between how your brain might react in terms of what you're measuring, but then also how you act upon what the brain tells you. And that I wonder if that's also sort of a potential aspect of some discomfort, right? So your brain still keeps telling you that there is something, and you're like, I know, please don't bother me. So it's almost potentially goes in the opposite
I'll tell you what,
direction
you don't even
of comfort.
Right. So you don't even need to be using the example that you've posed, which is every day for a week, right? So we are starting to be arguing amongst ourselves, those of us who analyze ERPs, in terms of how many trials do we need to grand average over in order to get a representative waveform of our question. And I'll explain to you why. So the more trials you have, the more likely it is when you grand average the ERP response, you're going to get a much cleaner signal without all the electrical noise, because that gets averaged out, right? But again, because of adaptation, it's been rightly pointed out that in fact, the amplitude of your waveforms, actually the underlying components actually do get smaller throughout the experiment, right? So you might average so much over so many trials that you get a really nice looking clean signal that high impact journals like, but it's no longer truly representative of the nuanced differences at the earlier part of your experiment itself between your different test conditions. And that's the topic of active debate, actually. How many trials do we need to average over in order to get a representative signal?
Okay, so next is a question from Abdallah.
Hi, so thank you, Lewis, so much. This is coming from maybe a different angle, but in the beginning, you started talking a little bit about continuous sensing with, say, physiological measures. And I know in like these very controlled studies, we can control, for example, one sound coming in and whatnot. But if we are to have, let's say, sensors all the time on us, at some point we have to ask the user for what they're experiencing so that we have some kind of ground truth about what it is. So I'm wondering, and typically when we run these studies, the fact that we're asking the user to input something is kind of changing the user state somehow. They might actually get annoyed by the prompt to give a self-report. So I'm wondering, what ways does neuroergonomics have like to deal with this issue, or is it just a matter of clever timing? You know, say based on an EEG spike or an EDA spike, that's when we ask the user to tell us what's going on. Or maybe the way you deal with it is just by looking at behavioral things. So
just to be clear, is this a question about labeling? About labeling
to an extent, yes. Or making sense of the signals, basically. How do I know that this ERP component now corresponds to specifically to this thing that I'm experiencing?
So the honest answer is, and I see we're still being recorded, you can never truly know, right? Because the labels that you will use anyway, and this is where I get a little bit philosophical, but not without reason. The labels that you use in any case, even by an objective researcher, that's going to be confined by the language that you use, right? When you talk about the 6 basic emotions, you're still using words that's very much tied into the cultural perception of there being happy, sad, angry. So it's always going to be, So what I'm trying to say is that even if you have labels that you trust, that comes from self-reports of highly self-aware participants, you are still relying on a model that contains implicit assumptions. So I wonder if you and I can first agree on that, right? Okay, because many computer scientists, if they're interested in the job of categorization, of classification, they would go, what's your ground truth, right? Assuming that there is a truth, an objective truth, that we would then compare it to, right? And I'm saying that truth doesn't exist, but its replacement of a model with implicit assumptions isn't that bad. It is what it is. It is what we have, okay? And if we can accept that as a starting point, then we're on the same platform for discussion, okay? Because if you have a model for which you design your experiments, for which you're looking for things, it's true that model might shift over time. People might have different perceptions of what the underlying mechanisms or the underlying basic labels of emotions might be, but at least we're all still having a conversation that's anchored in the same model. And that's what I do in my research. I acknowledge that the model that I have to say that these waveforms should be interpreted as, in the early part, orienting, in the later part, context updating, that might be the wrong model or the wrong semantic labels to be labeling these components. But as long as I have colleagues who accept the same labels, right, they will use my experimental findings as a basis of discussion or of gaining some kind of insight into the experiment. So that's my hand wavy answer to your question. Did I kind of answer your question, or should I go on and flap my arms a bit more? Yeah.
No, it's good. Yeah. And just, I mean, I use the term ground truth just because this is the term commonly used, but of course,
yes, absolutely.
I think
so. I think what we need.
Sorry,
that we have a time lag between us. So I think what we really need are widely accepted, established models, right? For the scenarios that we're interested in, for the mechanisms that we're interested in. And then we can actually have a meaningful debate across colleagues as to whether or not the model was correctly applied to that situation. And if not, then, then we have to update our models, or we have to, we have to reinterpret our responses, our findings. And in that sense, I guess I'm a proponent of forward modeling rather than inverse modeling. even if it's done very casually, right? As an experimentalist. Yeah.
Great, thank you so much.
There were various hands raised, but given the time, I want to round up the first part of the conversation, and then we can continue without the recording, because the hands also got up during specific parts where you said, I'm going to be a bit philosophical, and then a hand was raised, and a computer scientists say, and another hand was raised. So maybe some of those comments are...
So I'd love to hear from Leon, but I'd also especially love to hear from maybe someone I've never met before, like Pretty VS, if there's time.
Yep. So we'll do that after I close the recording, so we can continue the conversation a bit. But otherwise it gets so lengthy. Thanks, Lewis. There's still lots to
thank you for the invitation.
Discuss. This was good. I've learned a couple of things on how to pitch my own ideas and motivate this field. I'm still curious about where the field is heading. That was my other question, but we'll talk about that outside of the recording. So that's the reward for the people who are here. That we'll talk about that a bit. If you want to know what CHIWORK's up, then apart from our website, you can check the Twitter handle at CHIWORKSimp. Next week, same time, I think, Neha Kumar will be talking to Maggie Jack of Cornell Tech about making memory live, internet tools of Cambodian media history. So we hope to see you there. Thanks again, Lewis, for a great conversation. We'll continue it a bit after the recording stops.